Although example 3 serves nicely as a function from graphs, it is also an example of a function that must be constructed by gathering relevant information from verbal description and putting it together in the right way. People who do mathematics for a living are accustomed to confronting that challenge regularly as a necessary first step in modeling the real world. Now, the next type of thing that we're going to do, we're going to build a function from verbal descriptions. Now, there is no fail-safe way to form a function from a verbal description. It can be hard work, frequently a good deal harder than the mathematics required to solve the problem once the function has been found. The 4-step problem-solving process from section 1.1 gives you several valuable tips, perhaps the most important of which is to read the problem carefully. Understanding what the words say is critical if you hope to model the situation they describe. Now, example 4. It says grain is leaking through a hole in a storage bin at a constant rate of 8 cubic inches per minute. The grain forms a cone-shaped pile in the ground below. As it grows, the height of the cone always remains equal to its radius. If the cone is 1 foot tall now, how tall will it be in 1 hour? Well, we've got a couple things here. When we're dealing with something falling out of the ground, we're going to be dealing with volume. So we're going to find the volume of a cone. Now, if you look in the front cover of your book, you'll find that the volume of a cone is 1/3 pi r squared h. Now, the other thing it says, we know it says as it grows, the height of the cone always remains equal to its radius. So what we're going to have here, we know that r is equal to h. The other thing we want to know, we want to rewrite the equation in terms of h because it asks us how tall. So my new volume would be 1/3 pi h cubed. Now what we're going to have to find though, we're going to find the current volume, and it says it's 1 foot tall now, which is 12 inches. So the volume equals 1/3 pi times 12 cubed. Putting that into our calculator, we're going to take 12 cubed, divide that by 3, and you get 576. So my current volume is 576 pi cubic inches. Try writing that 3 again. Now, we need to know how much is added. So this is going to be added volume over an hour. Well, it's adding 8 cubic inches per minute for 1 hour, which is 60 minutes. That'll be 480 cubic inches. So now what we're going to have to do, we're going to have to find the volume in 1 hour. Which will be 1/3 pi h cubed is equal to 576 pi plus 480. Now we had to do it this way so we can introduce h back into the equation. Now in order to solve for h cubed, we have to get rid of the 1/3, so we're going to multiply both sides by 3. Then divide by pi. Now in order to get h all by itself, we're going to take the cube root. So you get about 12.98 inches. So that will be your height in 1 hour. Now in example 4b, it says water is stored in a conical tank with a faucet at the bottom. The tank has depth 24 inches and radius 9 inches and is filled to the brim. If the faucet is open to allow the water to flow at a rate of 5 cubic inches per second, what will the depth of the water be after 2 minutes? Well, again, we need to find the original volume. So it'd be V equals 1/3 pi times R squared, which is 9 squared, times the height, which is 24. So what we're going to do, we're going to take 9 squared times 24, divide that by 3, be 648 pi. So there's your original volume. Now, the volume lost over time, it's going to be, it says here, 5 cubic inches per second for 2 minutes. Now, 2 minutes is 120 seconds. So if we take 5 times 120, that's going to be 600 cubic inches. Now we want to know what the depth of the water will be after 2 minutes. Now, one thing it doesn't really tell you is that there is a ratio. The ratio of the height to the depth is 9 to 24 inches, and it's going to stay constant like that. So my H over D, correction, my ratio of the radius to the depth, that means my radius, that should be always 3/8 of the depth. So what we can do here, we can say the volume, well, we don't need that, take that back. So 1/3 pi times 3/8 H squared. Remember, D and H can be interchanged. H will actually equal 648 pi minus 600 pi. So simplifying this further, we'll have 1/3 pi times 9 over 64 H cubed will equal 648 pi minus 600. Now this 3 goes here, so really we'll have 3 over 64, 3 pi over 64 H cubed equals 648 pi minus 600, which means H cubed will equal 64 times 648 pi minus 600 over 3 pi. Again, we're going to take the cube root of all this. That means we take the cube root of 64 times 648 pi minus 600 divided by 3 pi will give us 21.36 inches. So the depth of the water after 2 minutes will be about 21.4 inches deep. Moving on to example 5, we're going to let units work for you. How many rotations does a 15-inch radius tire make per second on a sport utility vehicle traveling 70 miles per hour? Well, here's what we know. We know the circumference will be 2 times pi times 15 inches, or 30 pi inches. That's how long that's how much it's going to travel in one rotation. So we know that it's going to go 70 miles in 1 hour. We also know in one rotation, 30 pi inches in one rotation. Now what we need to do is how many rotations it's going to do. Actually, we're going to have to flip this one around a bit. Because I need rotations on top. So we're going to start multiplying these. Now we're going to get rid of miles in inches. Let's change. 12 inches is 1 foot. And 5,280 feet is 1 mile. We've got to change hours to seconds. Well, there are 60 minutes in 1 hour. It's not a mile there, it should be minutes. And 1 minute is 60 seconds. Now, if we did this correctly, the only thing that should be left after we do some canceling is rotations in seconds. So mile, cancels with mile, hour, cancels with hour, rotations we want, inches cancels with inches, feet cancels with feet, minutes cancels with minutes. So now all we need to do is just put it into our calculator. So that's 70 times 1 times 12 times 5,280 divided by 30 pi times 60 times 60. That will give us about 13.07 rotations per second. Example 5b. A tire of a moving bicycle has a radius of 18 inches. If the tire is making 3 rotations per second, find the bicycle's speed in miles per hour. Now, what we have to find first, just like we did in the previous one, we have to find the circumference of this tire. So it'd be 36 pi inches, and that's going to be 1 rotation. Now, we have to be careful here. We need to have inches on top, rotations on the bottom in this case. And you'll see why in just a little bit. And we know it's going to make 3 rotations every 1 second. So now we need to switch, because we need to figure out in miles per hour. We need to switch inches to miles and seconds to hours. So let's change inches to miles first. 1 foot would be 12 inches, and then 1 mile would be 5,280 feet. Now switching seconds to hours, going to be 60 seconds to 1 minute, and then 60 minutes to 1 hour. Now we should have, if we did everything correctly, everything's going to cross out and we're left with miles per hour. And we did do that correctly. So really what we'll have 36 pi times 3 times 60 times 60 over 12 times 5,280. And that'll be in miles per hour. So in your calculator, we'll have 36 pi times 3 times 60 times 60 divided by parenthesis 12 times 5,280. and that'll give us about 19.28 miles per hour.